Very good morning. Today, we will discuss the concept of deep learning techniques. These sessions will provide you information in a short format rather than a regular class. See, by seeing this diagram, you can identify artificial intelligence, machine learning, and deep learning. Computer science consists of various categories of areas where we have artificial intelligence is one type of a branch. A part and parcel of artificial intelligence is machine learning, and the part and parcel of machine learning is deep learning. So start with artificial intelligence. Artificial intelligence is a branch of a computer science that always tries to imitate the human behavior. It may be reasoning, communicating, hearing, seeing, and so forth. Which means a machine that imitates the human behavior is said to be artificial intelligence. A machine that mimics the aspect of human being is said to be artificial intelligence. See, this is an example of a deep learning. When you type something in one language, that will be converted into another language is an example of this technology. See, when you have a deep learning, machine learning, artificial intelligence, whatever the aspects of human being are going to be integrated into a machine, what you call neural networking, artificial intelligence, machine learning. Here, the basic three definitions. What is meant by artificial intelligence? Artificial intelligence is the capability of a machine to imitate intelligent human behavior. That is, Google car is an example for that. Self-driving drones, creating art, creating poetry, and even Google Assistant, voice assistant such as Siri, all these are applications of artificial intelligence. Machine learning is a branch of artificial intelligence that the computers with the ability to learn without being explicitly programmed. That means a machine that is adapted to the new situations without explicit programming is said to be machine learning. Deep learning is a part and parcel of machine learning. Machine learning itself is a part and parcel of artificial intelligence that uses a specific algorithm, what you call ANN, artificial neural network, which are inspired by structure and functioning of human brain and is capable of self-learning. So, artificial intelligence is an ability to imitate the human behavior. Machine learning is going to be executed without explicit programming, a machine that is adapted to the new situations. By using ANN, artificial neural network, which imitate the aspects of human behavior in the terms of brain structure or a functionality. Say this, machine learning is a branch of artificial intelligence that gives the computers with the ability to learn without being programmed. Deep learning is a subfield of machine learning. You have to draw the diagram. Deep learning, machine learning, artificial intelligence. Next. Say this. In the case of deep learning, we have a process, what you call a learning ability. When you give something, these two elements seems to be same, tomato and cherry. Tomato and cherry are differ in the terms of a size, in the terms of a type. Here, in the case of deep learning, we can differentiate both these components working of neural networks. So, if you write, someone may write 9 like this, 9 like this, or like this. human brain or a human can identify which 9 is correct, or he can identify these 3 elements are correct. But how machine is going to be recognized? That is under the concept of deep learning. So, as you know, John McCarthy, father of artificial intelligence, always trying to perform intellectual tasks which are normally performed by human beings. But artificial intelligence may also have some kind of flaws, some kind of errors. Artificial intelligence in long term may kill the human skills. Artificial intelligence makes the human thinking unthinkable. That's why many countries are discussing to have a kill button for artificial intelligence based robotics. Whenever they perform malfunction, automatically we have a button called a kill button in order to dismantle the machine. Definition of artificial intelligence. This is a theory and development of computer systems that are able to perform the task normally requiring human intelligence, such as visual perception, speech recognition, decision making, and translation between languages. That means it always concentrates on perceiving ability, that is human thinking ability. It includes various specializations: game playing, robotics, natural language processing, NLP, expert system, neural networking, and so forth. I told you earlier, Google car or self-driving drones, mathematical equation solving, even natural language processing, and so forth. Artificial intelligence, engineering of making intelligent machines and programs, whereas machine learning, ability to learn without being explicitly programmed. Deep learning, learning based on deep neural networks. Second definition, machine learning. I told you already. In general, whenever you give input and algorithm, normally machine produces output. Whereas in the case of machine learning, when you give input and set of rules, it produces, or if you give input and required facts or outcome, the machine itself can produce set of rules. How it produces a set of rules? Based upon previous experiences, based upon previous knowledge, what you call knowledge base. Machine learning is a type of artificial intelligence that provides a computer with the ability to learn without being explicitly programmed. See this? When the classical programming model is concerned, we are giving set of rules and the data, set of rules or algorithms, which produces answers. Whereas machine learning is considered when you give data and answers, machine may produce a set of rules. How it is possible? This is possible only through a concept what you call learning from previous experiences. Such a data is said to be training data. Such a data is called training data. Right. See this? Machine learning and deep learning. See, some of the screens, some of the images are collected from internet sources. So machine learning, when you give input, there is a feature extraction and feature classification. We produce an output. It's a car or not a car. It's a machine learning. Whereas deep learning is concerned, when you give input, it uses neural network structure, where we have set of hidden neurons exist that produces output. Deep learning clearly produces it's a car or not a car. If it is a car, then color is red, maker is a Ford, model is so and so, the dimensions is so and so, structure is so and so, like that. Whereas machine learning may not provide all those details. It may provide only the information whether it is a car or not a car. Right. One more definition for artificial intelligence. Artificial intelligence is the ability of a computer to perform the task commonly associated with intelligent being like a human being. Machine learning is a study of algorithms that learn from the examples and experience instead of depending upon hard-coded rules and make the predictions on the new data. Just now I told you, machine learning, machine learning always produces an outcome that is in the terms of rules. We are not giving any kind of rules. How machine learning process that is possible through examples or experiences, also called as training. Deep learning. Deep learning is a subfield of machine learning focusing on learning data representations as successive layers of increasingly meaningful representations. It includes number of neurons. Like a neuron structure in a human brain, it works. Some layers may be visible layers, some layers may be invisible layers. See, deep learning may have many AI applications. It may be voice-enabled technology, credit card fraud detections, or anything. See, this diagram is very important. Neural networks, which are organized in the term of layers that consists of set of interconnected hidden layers. This is the input and this is the output, where we have input layer, and finally, we require output layer. Internally, we have invisible layers, what you call hidden layers. Some examples of deep learning. See, I am giving information only for your examination point. For example, they may ask you a question, a very important question in the first unit. That is, write about artificial intelligence, machine learning, and deep learning, or compare machine learning, deep learning, artificial intelligence. So you have to start with this introductory part, which may provide you maximum amount of vocabulary while writing deep learning theorem or theory. Virtual assistant, I told you Alexa, Siri, or Samsung, any Google assistant, everything, whatever. For example, you used to ask your smartphone about, hey, represent Google. What is the time? Or, hey, Google, what is the route from Guntur to Tenali? Or something like this, which may provide you a information in the terms of a human. Self-driving cars, we have autonomous vehicles, where all those vehicles may provide some kind of deep learning algorithms which determines whether car is going to follow exact guidelines that are given by the traffic police or follows the guidelines that are in the terms of boards or in the terms of road, in the terms of a path, etc. And it reacts accordingly like a human being, but no human involvement exists. It's a deep learning. Chatbot, you all know nowadays chat GPT is also part and parcel of this technique. Chatbot is some type of a technique which is basically in the form of artificial intelligence that will be converted into machine and then deep learning. When you open licindia.com, there exists a small robotic type structure in the terms of a chatbot. A chatbot is a type of application which provides you assistance to the human being without assistance of a human. Without assistance of any human being, it can provide you assistance to the users, even though there are no employee involvement exist. Next one is facial recognition. Nowadays, we are using face recognition applications. In many areas, it may be smartphone, laptop, or even for your attendance also. So it is going to be, it can easily identify all categories of applications when your lighting is very poor. In the case of a getting application, then you may not recognize poor lighting, birds, hairstyle, etc. It may differ. Medical sciences for identifying DNA pairs of chromosomes, medicines, diagnosing tumors, medical purposes also, we are utilizing deep learning, speech recognition or voice recognition. Even some kind of conversions are also there. Whatever the information you are giving, that will be converted into type of text. Next, one more definition in a detailed manner. What is deep learning? Deep learning is a subfield of machine learning that is based upon learning several levels of representations corresponding to a hierarchy of features or factors or a concept, where high-level concepts are defined from the low-level ones, and the same low-level concepts can help to define many higher levels, which means deep learning is equal to machine learning plus representation logic. What is representation learning? Representation learning is a mechanism of a element which which is connected with the raw data and to automatically discover the representations needed for detection or classification. What are the unique characteristics of deep learning? Automatic feature extraction. I told you in the first diagram itself, feature extraction, feature classification, feature prediction. Makes use of high dimensional data for the training. As you know, there are, in the case of data warehousing and mining, we used to have multi-dimensional data. Defines high-level features from the low-level features obtained from the previous layer, what you call interdependency. As you know, output of one component will act like input for some other component is said to be interdependency. Representation learning method can solve real world or unconstrained problems. There is no constraint. What is a constraint? Constraint is nothing but a condition, such as natural language processing, image recognition, etc. Some of the deep learning softwares may include TensorFlow, Techno, Torch, PyTorch, what you call PyTorch, Keras, Blocks, Cafe, Cafe2, MXNet, etc. These are not some. We have huge amounts of applications exist. Now, brief history of machine learning. I told you deep learning has reached a level of public attention and industry investment never before seen in the history of AI, but it is not the first successful of machine learning. Many applications exist, but all applications may not be deep learning applications. So we have a concept what you call probabilistic modeling. It is a mathematical representation of a real world process which incorporates uncertainty or a random variable. What is uncertainty? Whenever there exists some kind of ambiguity exists, there is no clarity exist, such kind of activity is said to be uncertainty. As you know, we always have collecting the data in the terms of KDD, knowledge discovery from the databases, which is the concept in the case of data mining and warehousing. We have a raw data. Raw data need to be collected, data collection, whatever the collected data exists, that should be integrated, what you call data integration. And then we need to perform data cleaning. Unnecessary parts of data need to be eliminated. Sometimes it may include redundant data need to be eliminated. Inconsistent data need to be identified. You need to fill the values in the case of uncertainty. So here, probabilistic models are used in a variety of machine learning tasks such as classification, regression, clustering, dimensionality reduction. See, all these topics are already covered in your machine learning and data mining and warehousing. Some popular probabilistic models includes GMM, Gaussian mixture models, hidden Markov models, Bayesian networks, Markov random fields. Just now I told you these are the models which are well suited for handling uncertainty and making them particularly well suited for real world applications where the data often contains some noisy or incomplete. What is noisy? Noisy is nothing but uncertainty, inconsistency. Whenever the data is incomplete, for example, if we consider student attendance, while collecting, while recording the student attendance, every faculty member or a staff member usually records the student attendance based upon his roll number or her roll number. Someday, if you want to predict whether the student attended for the college or not, in such a case, we are going to collect the data from the previous experience. If a student opts in for 25 hours out of 26, then we are going to make our prediction is absent today. If a student attend for the college 25 hours out of 26, he was present. Now our prediction is present. This is called as predictive modeling, where we have incomplete data, noisy data is going to be handled. So this model is a combination of statistics to data analysis. So here, one of the best known algorithm in this category is a naive-Bayes algorithm, which is based upon Bayes theorem, which is completely in the terms of data analysis. So Bayes theorem and the foundation of statistics date back to the 18th century. There is all or need to start using naive-Bayes classification, logistic regression, regression algorithms, predicates, classification. All these are the components which are under probabilistic networks, early neural networks. See, early generations of neural network have been completely replaced by modern variants, where we have a backward propagation, back propagation, convolution theories, what you call CNNs, etc. Now move on to kernel methods. See, kernel method is nothing but some kind of mathematical approach which can be used for analyzing the data related with machine learning. Very simple. See, kernel method is a mathematical technique that is used in machine learning for analyzing data. These are group of classification algorithms, best known which is called SVM, that is support vector machines, SVM. So this is a boundary of addition. This is a figure which represents some kind of information between two categories. One is solid, one is thick bullets, second one is hollow bullets. Here, this is a decision boundary in between two categories. A decision boundary can be thought of a line or a surface which separates your training data into two spaces corresponding to two categories. See, SVM proceed to find these boundaries in two steps. First one is, whatever the data we have that is mapped to new dimensional representation. Second one is, a good decision boundary is going to be calculated by trying to maximize the distance between hyperplane and the closest data points from each class. A step is called maximizing the margin. So there are kernel tricks comes into these areas based upon computationally tractable or not. That means based upon SVM, we are going to identify which one is outside, which one is inside. Next one is decision trees, random forest, and gradient boosting machines. Before moving on to these decision trees, you need to have some kind of idea regarding conditions and set of rules. There is a decision table. For example, if I give you a query or a statement that if rain is predicted or raining, then carry umbrella. If rain is predicted or is it raining, then carry umbrella. Rain is predicted. These two are called conditions. What are the outcomes? What are the outcomes? Those outcomes may be carry umbrella, do not carry umbrella. What are the conditions? Rain is predicted. What are the set of actions to be executed? That is That is, carry umbrella, do not carry umbrella. Yes, raining or rain is predicted, then carry umbrella. Rain is not predicted, carry umbrella. Not raining, rain is predicted, carry umbrella. Not raining, rain is not predicted. Again, there is no need to carry umbrella. This is set of rules. In such a way, we are representing decision tree. Decision tree is like a flow chart that can be used to classify the input data points or predict output values based upon given inputs. These are graphically represented in the terms of classifications. See this? Here we have input data, question, and final leaf elements would be category. See, in the case of your machine learning previous semester subject, we have a concept what you call whether somebody is going to enjoy the sport. Whenever the weather condition is forecast is rainy, outlook is rainy, he's not going to enjoy the sport. Whenever the wind speed is very high, he is not going to enjoy the sport, or he may not be playing the tennis. In such a way, we have next point, random forest algorithm. Random forest algorithm introduced very reliably, very strongly, based upon decision tree algorithm that involves building a large number of specialized decision trees and then grouping them based upon their outputs. Ensembling is nothing but grouping. Random forests are applicable to wide range of problems. We could say that almost always the second best algorithm for any shallow machine learning. See, there is a competitive website, machine learning, remember this name, machine learning competition website, what you call a Kaggle, got started in 2010. Random forest quickly became a favorite on the platform until 2014 when gradient boosting machines took over. So it is based upon weak prediction model. Gradient boosting machine is completely based upon weak prediction model, generally decision trees. So what is our intention? Our intention is always trying to increase the ability of learning components by performing iteratively training new models that specialize in addressing the weak points of previous models. See, whenever a new model is emerged, our ultimate approach is to verify the drawbacks or the flaws of previous model. We are trying to remove those flaws and provide best outcome. So learning representations from the data that is based upon input points, or our ultimate aim is to produce outcome. For example, in a speech recognition task, these components could be human generated transcripts of sound files, and in an image task, expected output could be a tag such as dog, cat, and so on. Next. So consider there is a diagram in the terms of coordinate change, raw data. This raw data have a component in the terms of boundary. There is addition boundary. We can classify these components in the terms of coordinate change. In a better way, we can represent these components. What we need here is a new representation of our data that cleanly separates a white point from the black points. One transformation we could use among many other possibilities would be coordinate change, illustrated in this diagram. This is, see, whenever we have the information like this, which can provide you better way of representation in which the components or the coordinates are clearly identified. That's all.